Thanks everyone for being here. We are here to talk about Sakai DevOps Nerdvana this morning. And we're hoping to kind of break the session up in a way that we allow for at least a good 10-15 minutes of Q&A at the end. So we were hoping to get into some fairly good questions there. So we'll try and save those for the end. I'm Lance Spielman. If you guys don't know me, we've got Mike DeSimone here with us this morning as well. So, hi everybody. Okay, so I thought maybe I better start by defining what the heck Nerdvana is. I use the quintessential authority on such matters, the Urban Dictionary, and basically is defined as a state characterized by happiness and satisfaction of high-tech gizmos, which I think we've all experienced one time or another in our lives, or a state of total geekdom. So the question is then, how does one achieve a total state of geekdom? Well, the one thing that I'm probably pretty sure of, as far as geeks are concerned, speaking, as one of them, is that geeks like to make technology work for them, among other things. But that's one of the, I think, one of the traits of geeks. And so one of the ways that we make technology work for us is allowing us to do more than we could do without it. So, this is, I find, most days, it seems like for me nowadays, a lot of my time is spent stating the obvious. And so I know this is stating the obvious, but I just wanted to, kind of lay a foundation here of why it's so important. And so, if I reflect a little bit on, historically, we've had, some very talented system administrators that have been working with physical machines in machine rooms or closets to build infrastructure that didn't exist before. But something's fundamentally changing in the world around us. We've got Amazon Web Services. We've got a number of cloud folks competing with them in the cloud space, and of course that's all virtualized technology. And even if you're still working with with big iron, so to speak, you still need to use some of the techniques that folks have been developing over the years to make that easier for yourselves. And so, as much as anything, and we've been hearing this for how many years now with the economy, is we just have to figure out a way to do more with less, right? So the question is how? How do we do that? And again, Captain Obvious here. We're going to create some brand new capabilities that we didn't have before. And these kinds of capabilities are going to take a shape of, I sort of liken it to building a fully automated assembly line completely in code, right? But at least from our perspective, from Asahi's perspective, a fully automated assembly line is something that all of a sudden frees people up to work on other things that they might not otherwise be doing if they're continually babysitting deployments, upgrades, hardware, software, things like that. So as much as anything, it's important for us, we feel like, to focus on those new capabilities that allow us to do more with less. And specifically, in this session, we're going to be talking about DevOps capabilities. So that kind of led me to, okay, well, what the heck is DevOps again? I know I use that term a lot nowadays, but it's always good to remind myself what it means. And so in doing that, I learned another new word. I'm not sure I'm going to try and pronounce that for the first time in front of a crowd, but thank you. Portmanteau. So it's literally the combination of development and operations. And, one of the things that's going on in the world around us, and hopefully, in your institutions, is making it easier to get code deployed, to keep, to keep a team agile so that they can do deployments faster with more reliability. If you look at a site like, say, GitHub, those folks are pushing code hundreds of times per day. Very small little fixes, but their framework, their automation allows them to deploy small little fixes across the entire operation, literally hundreds of times a day. So that's sort of a whole new ball game, right? That puts you in a position of power that without it, you really couldn't think about solving problems that way. And so it's really getting yourself into a position where you can do things quickly and with high reproducibility. So that's what kind of married those two things together. People started thinking about operations more from an engineering perspective, and how can you make operations work for you? And so again, went to another quintessential source on knowledge, Wikipedia, and I thought this was pretty interesting way to put it. And as much as anything, it's the goal is to automate as much as possible at its core. And I think that's a pretty fair assessment of DevOps in general. So, like I said, the one thing that I've learned over the past couple years, getting to focus on DevOps, is that it's not something that you can enter into lightly. And if you don't have some engineering capability on your team, it's not really going to be an option for you. You need to think about solving problems, figuring out what's the lowest common denominator, what technologies can I use to reproduce that. How am I going to weave all of these capabilities together, into some workflow that all of a sudden is making me more efficient? And that's pretty clearly in the realm of some form of engineering. So it has to be approached that way. And when you don't have that ingredient, DevOps will tend to sit and spin. So with that, I'm going to turn it over to Mike and let him tell you.
Sure.
Tell you some more.
Okay, so to get to this Nerdvana, then what are we going to do? What are we going to achieve and accomplish by bringing some new technologies to bear, and how is that going to help streamline the operation? Because the end of the day is you need to be agile. You need to respond to changing conditions. Perhaps you need more resources. You get more users for finals. How do you maybe prepare for that temporarily? And so some of the value proposition here and the things that you can achieve by really diving into the DevOps and utilizing some of the technologies out there is you can more quickly achieve if the end goal is to have a new system, a test system, or you need to add resources to your existing production system. You can do that a lot quicker now if you set up the foundation. And I'll explain a little bit about what that foundation is. But one of the nice things is that you can sort of use Puppet is the main technology we're going to be talking about here, and that's the underlying sort of language that does this. And what it does is you define things once, and then you can repeat them, deploy them, you can push things out. There's only one source of this configuration information, and that can really reduce errors. I mean, there's still code involved, there's still errors that can happen, but you can fix them in one place, and it can be a lot better because previously maybe system administrators, they have their own little set of scripts that they kind of do, and how does that scale, right? So and centralizing some of this knowledge as you either find better best practices or you just modify or expand upon your knowledge, you just again in one place, and then with a little deploy it out there to everyone, and all of your best practices get applied relatively easily. So can go. And so this slide is sort of it gives a summary of some of the technologies in play here. So Puppet Labs is the entity that sort of maintains the Puppet code language and stuff, and it's its own language, but it has some components of Ruby expressions involved and that kind of thing. It's a declarative language, and you basically create some Puppet code to define your desired end state. So we're talking about deploying an app server, deploying a database server, deploying an Apache load balance server, or something like that. You sort of define what the end state is, and the end state is what software is running on the machine, what users are on that machine, what their roles are on the machine. So you can think of different classes of users that could have different access to these machines. So you could have sort of, the admins need root access. Support folks, they might need to get on to do some limited functionality, check log files, perhaps, right? So using so there's a lot of plugins for this. So Puppet is a core language. The Puppet Labs has like a marketplace of, I don't know, dozens or hundreds of different modules and plugins that provide. There's an Apache one, right? So you pull in the Apache module, and then other folks have kind of puppeted the deployment of an Apache configuration, and so you can kind of pretty quickly get up to speed and start leveraging this knowledge, and you can fork it from GitHub, and kind of, if you have any local best practices want to incorporate, you can kind of put it in there, customize it for your purposes. So then you define the machine states, you define your users. One more minute on the slide, sorry. Okay. And then you get your machines to the state you want to have them in, and then Capistrano is another automation technology which can then deploy the code, among other things. I think it's similar to the M collective that people talked about yesterday. In a sense, it sort of performs actions on a bunch of machines at once. And so I look at it as there's a split between defining your machine states with the Puppet and then deploying your code with Capistrano. So, and I just these other ones, before you might have had CentOS, a bare metal machine maintained. There's like dozens of them, and it's pain to kind of keep them all up to date. Then maybe you got Citrix, some virtualization, VMware, and that's a little bit better. Maybe you have a like a virtual machine template that you can clone. Not bad. That's getting a little more consistency, right? But how do you maintain that? And things can then drift once they're out there, right? So then, if you move to the Puppet way of thinking about defining your machine states, yeah, you can have these machines out there. If you do a Puppet apply, it'll look in its central base of your declared state, and it'll fix anything that varies from it. So if you have some rogue people kind of trying to mess with your cron table, this will fix it up. So it keeps everything very ordered. It keeps the RPMs at the right version and all that kind of thing. So it's a nice way of really promoting a lot of consistency, and as well as providing a way of really quickly getting a good production or a test machine configured the way it should be. So
we'll have some more time at the end to dive into any of the details that we want to explore as a group. One of the things I did want to talk about was some of the user stories that we're trying to implement with the automation technology, just to sort of set the stage of some of the workflows we're concerned about. So we would like sort of analysts in the company, whether they're in services division or they might be in marketing, to be able to create new stacks on their own. So that they can say, I need a new demonstration instance, or I need a new production instance for this institution. Boom, they can provision that stuff on their own, don't have to get operations involved, and can be pretty much a self-serve operation. The other workflow that we find is important is, okay, now you have one of these things, and I need to create a copy of it because I need to try some stuff, right? I want to test some new code. I want to test database changes. Whatever the use case might be, it's useful to say, I've got one and I want another one just exactly like it, right? And what's interesting there is, sometimes it can change shape along the way. You might start off with, say, a production cluster, but when you create a clone, maybe you just need a single machine just with the right data on it. And so that's another story that we're pursuing. Of course, you've got to plan for upgrades, and upgrades when you do tens or hundreds of these things become a big deal. And so creating the consistency and the patterns that we can use to move through those activities will be important. And so again, this is something I would like to be able to give to the analysts so that they can indicate, okay, this customer's moving towards an upgrade, and therefore we need to start a test instance upgrading from version A to version B every night, so we can start validating that. So that'll be an important workflow, and that they'll use the same technology to actually perform the upgrades. One of the things that's kind of interesting, once you have some of these automation capabilities, is that you can think stacks all of a sudden become throwaway because you can reproduce them so easily. You're not afraid to throw things away. And so you could imagine a scenario where I start off with a production instance A, I do all my validation on an upgrade in a brand new stack, new machines, I get it just exactly the way I want it. Well, instead of throwing that thing away, you might sort of change your thinking a little bit and throw the old thing away and keep the new thing, right? And just change its identity to become the new production thing. And so you have a ton of flexibility in those sorts of automation workflows. So that's at a high level what we're trying to achieve with the automation, the sort of operational capabilities that we're trying to give ourselves so that we can do our job more effectively. And these same techniques can be used in a variety of software related deployment development tasks. And so my challenge to you in sort of this session is to think about it differently, think about ways that you could use it, and then maybe we'll use the time at the end to talk through that a little bit and see if we can't get some action out of it. So with that said, I thought we might take a few minutes just to take a look at some code. I'd set out a couple days ago. I love to procrastinate, so I worked on my presentation yesterday and recorded this little screencast. What you're looking at originally encompasses 27 minutes from beginning to end, from me hitting enter on that command line to a completely built CLE 2.9 machine, fully configured, and me able to point my web browser at it and take a look at the home page. So in this case, I'm using Amazon. One of the things Mike talked about earlier is that we're also our two target environments would be, say, Amazon Linux and CentOS, and so the automation technology supports both of those environments. So we can go cloud Amazon, or we can go on-premise CentOS, co-location, and really use the same approach in both cases. And so here you'll see basically a process that's occurring now is check out the base Linux, and so we'll go with whatever the latest CentOS is or whatever the latest Amazon Linux is. Get as current as possible. Get it fully patched. Make sure that whether it's CentOS or Amazon, that it's fully all the Yum packages are up to date. If you're using Red Hat style, get just enough of binaries and config on the machine so that we can actually run Puppet. And then everything else from there is Puppet basically getting the machine into the state that you want it in. So now probably 60 seconds later, we're through the point where Puppet's been applied. The machine is since rebooted so that it can load any kernel patches that came through in that update, and then it's starting up Sakai. So I also cut some of the startup time here out of Sakai to kind of cut to the chase.
But I mean, just to kind of talk about what it all did, I mean, it downloaded and installed the MySQL binary. It set up users, the root users, a bunch of support users who can query the database. It set up Apache load balancing. You know, it's if there's SSL involved, the certificates, it'll kind of install that, get it all ready to go. It pulled down Tomcat, expanded it, and then we deployed the code into it. So it kind of flew by a little, but you might have seen some Linux users get created for support folks, stuff like that.
So prior to when Puppet takes over and actually starts configuring applications that are just, is this all like shell scripts of some kind?
The part prior to Puppet? Yeah, so right now the bulk of that is just Bash. Yeah, just some simple Bash scripts to get just enough on the machine so that you can run Puppet.
So we sort of start with just a minimal OS image. Either there's Amazon provided Linux or a minimal CentOS if we're working in like a VM environment. You just start with the minimal thing and you define to Puppet all the packages and everything else. It'll get it all sort of configured very consistently. So you'll always know what you wind up with. That's the really nice thing.
And one of the ways that it's changed our behavior, in the way that we define done in the company is now you can't call it done unless it's automated. No matter how good whatever the thing might be is, if it's not automated, it doesn't really exist because it's just not part of the workflow, right? So it's a big push to sort of get people to think about it that way, so that we continue building on that those capabilities.
There's a question back there, I think.
Yeah.
What are you using for your provisioning portion of that workflow?
Provisioning of what?
Like,
I think, it was sort of there's a bash script, and, in the case of Amazon, we can use some of the EC2 command line APIs. So we kind of call out, create a new machine, we say we want this, Amazon has its nice little base image, and we say use that one, clone that into a new, M1 large instance on Amazon or something like that. So there's some bash scripts. The same, similar ones, different parameters are targeted to Zen or something, VMware.
Yeah, so pretty basic. We're looking at CloudFormation, as a way to improve on that aspect of it. CloudFormation, Amazon adds some rigor around, the expression of maybe say like a cluster. So that a lot of that, in like one web service call, you can say, spin me up an entire cluster of machines that looks like this and has, these connections. And so that, that again will, go through some continual improvement. But the stuff, that I was showing in the demo there is, some fairly basic. Just call, EC2 start instance and pass it a bunch of parameters.
So as an example, we're doing this. We can set up sort of a test stack for this, and someone said, "Oh, I can't log in," and I'd forgotten to put them in the list of users to provision. So you added their login name, do a Puppet apply on that machine, and like a couple minutes later, they're able to SSH in with their key and all that stuff. And so it allows you to do things quickly, easily. Adding one login name to one file is a lot more, a lot less error prone than like user add and then making a .ssh and making sure the permissions are correct and all that stuff. We all have done it, right? But now you just add their username and boom, it's done. So that's kind of an example of how this changes the administration of stuff. So
and so Puppet's some really great technology, and the stuff we just showed in those 3.5 minutes represents somewhere around 2 years plus of effort of multiple people getting that all to work just right, and so it's not easy and when you hold it up to say an application like the CLE, or maybe a war-based application, whatever that might be. A lot of that workflow and automation are things that you've got to create your own, probably for some legacy reasons, right? An app was designed a certain way, and therefore that means I must do it this way. And so a lot of this automation you've got to customize to work in that way. One of the things I wanted to kind of just contrast with, just to kind of seed an idea, is I was talking about earlier about what's going on in the world around us, and depending on what technologies you select, all of a sudden the problem can get much simpler than even the level of investment that we showed. And so, just as a comparison, I just wanted to, give you a short sampling of something, a service called Heroku, that supports a number of languages, and Ruby on Rails is one of them. And so, if you did select that technology to write your tool in, all of a sudden, some really smart cookies out there have done an awesome job of basically handling all of your DevOps needs for you. Basically, it's like DevOps in a box. And you get to use it and learn how to use it for free. So it's pretty damn cool. So here I'm showing basically a Ruby on Rails tutorial. It is currently configured with Heroku, so you can see there's a URL, right? Load up my little tutorial page, and in this case, it's like, okay, I want to change the header 1 on that page. And so what does it take to go from making a change in code to deployment and the turnaround to get that thing back into production, right? So here you can see I've made the change in the text editor. I'm committing it to source code, which regardless of what you're using, there's a pretty good chance you're using source control, right? So this is just normal developer workflow. And then you see, using a git push, just the same way I would push this code up to GitHub, I'm pushing it to Heroku. And so Heroku does this cool thing where basically they hook into the git commit as a hook, and you can see now their code on their end is detected, this is a Ruby on Rails app, right? So it goes through all of its normal deployment. One of the coolest things that Rails does is all of the HTML, CSS, JavaScript, right? That all gets minimized, MD5'd, all the best practices around managing assets. They've got these things they call slugs. So basically, it's a small little virtual machine, and boom, that thing's done. I've gone from code change to a push, and all of a sudden, that thing is now in production. And so you can see here, Chrome reloading the page. So that's, that if you think about what sort of capabilities that might give you, and Heroku's not the only game in town. There's others, there's multiple languages, but all of a sudden now you have essentially DevOps, by default. And, that's really cool. One of the other things I'll mention real quickly is some of the other tooling, depending on your technology selection. This same Rails application that I was demoing, I'm using a service called Travis CI, which for GitHub projects that are open, basically you get continuous integration for free. And I hope that's free forever, but I'll take free for right now. And so yeah, basically you just hook it up to GitHub, and it's like anytime I commit anything, I want you to go build it and run the unit tests. And so you see this is my little Rails sample app, and my last commit, it checked out the code, ran all the tests, and boom, I got the green light 113 unit tests later that everything's cool. And so that keeps that again just shows you in today's age technology selection is huge because there's an awful lot of tools out there that can make your life really, really easy. So think about that, and if you can't get into one of these cool services, create some stuff yourself, use some automation technology to build the capability yourself, and it will pay back in droves. So with that said, maybe we open up for Q&A at this point.
So, what are we going through, like after you get these stacks up running, stuff, that environment set up, there's other things that sort of, right, need to happen outside around monitoring. Something's going to ping this, monitor it, do some stuff around maybe help with root cause analysis and stuff. So there's sort of like other systems that then look at these things you deployed, and how's that? What's the thinking around that?
Well, I mean, there's a few ways to handle some of that, and I think, for example, with Logstash to help manage and collect all your log data, there's a Puppet module that can be deployed to do that. So, we forgot, we just discovered this is a good way to do it. Pull down the Puppet module, configure it into your Puppet code base, Puppet apply, and then all the nodes you apply it on will have a Logstash little client put on there, and it'll be hooked in like that. And for monitoring, there's different ways to do that. I think, obviously, we've been looking at an external, maybe there's an external registration service that can, these new things can be told to call into to register, and then monitoring can then be set up or something along those lines. So there, in that case, that might be an external kind of service, but maybe the callback or whatever, that can be automated so that every new server is going to know how to call home to set up my monitoring or something.
We use modules.
We
and I think Puppet has some special resources for deploying modules resources.
Mm-hmm. Yeah, we've used that Puppet module, the Nagios module. Yeah, so the goal, though, at a high level, is to make sure all of that stuff, all the supporting systems, everything that's required to be what we consider production ready, should be all part of that automation cycle, so that at the end, you get all of it, every time.
And it's not. That's the kind of the game changer. It's not really done. Like, next year, a couple of years ago, Zap Dynamics, something with a Logstash, some new root cause analysis technology comes out next week.
Right.
You've got the infrastructure to deploy that everywhere universally.
Right.
Yep.
Very quickly.
Yeah.
So I consider this would be a very powerful tool for people who are doing self-development like a side or
Mm-hmm.
another commercial provider. But how could this be applied to the general types of development activities that Apereo is involved
That Aperio's involved in as a community.
in? Yes. Because we have these sort of collaborative development efforts, and it's clunky. You well know that's what it's like to work on Sakai or reprogram any of these things. This kind of technology is extremely powerful, and I can definitely see where it would reduce the release cycles, for example. But deploying it is non-trivial, I think, for a foundation.
I know that there's so one response is there is a good body of work that's available to the community right now, and there it's in right. We've got a Puppet OEE project that Eric Frogie, right. If you look at his GitHub repo, so that's a good start, and I think maybe was some of the basis for some of the work you guys used in OEE, right?
Yeah, we built on Puppet OEE. There's a Puppet Hillary repo that's in there now. We added quite a bit of other components as well for deploying different environments like staging, QA, production. I think as far as contributing shareable modules, if people created a Puppet module, for example, for their application, like CLE Puppet, that would put Tomcat out for you, and then check out the source code for you, grab a binary distribution for you, and have the configuration for people to do that in a flexible way for their environments. That would go a long way to share a lot of the work that goes into deploying CLE, as an example. You have a Hillary module that you could reuse for deploying just the backend portion, for example, as well as the front-end source code.
Who's hosting the virtual environment?
So we're hosting some our team is hosting virtual machines in the Joyent Cloud.
Joyent.
Which is similar to Amazon, just like
So it's a commercial service.
Mm-hmm.
Another notice, if you hook up Puppet to something like Paper,
you could, for a new developer, set up a VM, just run old bucket files, and you would have a new instance of CLE below you and whatever bucket scripts you're running, and then the 15 minutes.
Let's see these
Not ever easy, is it?
Well, and so the thing is, though, I mean, so that's all great advice, So the one sort of commonality, though, is so once you do that, right, and you sort of have this CLE capability, well, all of a sudden you realize, well, that thing actually is pretty similar to the shape and size of pretty much all of our Java applications, right? And mostly it's okay. I've got a war file I need to deploy and manage that, and so all of a sudden, by tackling the CLE problem, you've gone most of the way of creating capabilities that you could use in multiple disciplines, right? Multiple applications. And so I think the real power, if you were like a central IT organization, developing this kind of capability, across your enterprise apps would be a game changer, in terms of efficiencies. And so that would be cool. But I think even at the smallest, I've got a server in my closet kind of level. You can make your life easier by automating the stuff that you do. What are the workflows? What's the kind of stuff you have to do? If you can automate it, that means you're going to be able to have some more free time to either enjoy life or get more work done. But either way, it's a good thing. So, other questions?
Have you guys looked at other tools to fill the gap between your SSH scripts and getting your environments up and running? We looked a little bit at things. I think it was. I always get these two mixed up. I think it was Cloudify. The name comes from you can just define some kind of metadata about what you want your remote infrastructure to be.
Right.
You can either deploy locally on Vagrant or externally on depending on what kind of drivers you have. So either
So this is like a service.
Stack or Amazon or Giant.
So it's sort of like a front end to multiple cloud technologies.
Yeah, and then it uses Chef, but you could
Yeah.
Chef install that. Stuff.
Right.
I don't know if you've looked at that stuff or because we looked at it briefly, we couldn't really find that would work great with Giant.
Yeah.
We wrote a little tool ourselves to fill that gap for now. I'm not sure if you guys came up with some good technologies there.
So like in the Amazon space, Amazon uses an open source technology called Cloud Init. So it's a little Python package that basically allows you to send in some metadata when you launch the machine. You've got 16K, that probably is sitting in, DOS high memory somewhere, I don't know. But it's 16K that you can, poke some data in, and when the machine starts up, will extract, and so you can, bundle a little bash script in there, and so that thing will start executing as soon as the machine starts. And Cloud Init sort of handles okay, I run this once, or I run this every time, so it can handle I just run the script once workflow. So Cloud Init's good, and Cloud Init can be used on pretty much any Linux. So, getting that wired in is not too hard. But on the Zen side, our approach is fairly simple. It's we build our own little payload, and just copy that stuff to the machine with SSH or whatever, and then just kick off the process.
So there's a little bit of manual to bootstrap it, but after that it's maintained.
Yeah.
As long as it's not proportional to the number of machines you have to deploy.
Right. Yeah. That's
That's the key.
If you have to do that thousands of times, that might be a problem. Yeah. Yeah. So no, we've not looked at any of those that are out there. Good question, though. So one of the things that's kind of interesting about the whole problem space is you kind of go from worrying about, is that disk drive going to die, or am I going to run out of something, to how can I spend less money with Amazon, right? So you also start thinking about using the automation technologies in ways that can help reduce your monthly bill there. And so it's they work not only for making you more efficient, but also you can apply them in different ways for cost savings. And once you have it, it is sort of oddly. I don't know. I get kind of gleeful when I can just delete machines like crazy and know that I can reproduce them at will.
But also the freedom to spin things up.
What's that?
The freedom to spin new things up is sort of
Mm-hmm. Right.
because you can sort of complacent mindset that just spin it up to there's a moment inside. You better be deleting it after you're done.
Yeah. There has to be some control about who's creating all these machines in Amazon too, right?
So I think, Mark, I think maybe I didn't quite finish answering your question about what does the community do with technologies like this, right? So the idea that the community could start using some of it for, say, like the nightly machines, or as part of the QA process, I think there's some smart people working on that stuff, and they could definitely figure out how to put this to use. That would be one way.
I was aware that OAE was doing some of this. I hadn't quite actually made a connection in my mind for that. So once that came out, it's like
Yeah.
it's obvious that you are so.
Yeah, and then the thing with CLE is, of course, now CLE is 1 million plus lines of code. It's hard to retrofit with some of the, say, like test automation that we might like to have in there, right? So I think in a sense, I was talking to a colleague last night. It's you can the new success patterns are pretty well known, right? It's like start day one with 100% test coverage and keep it as close as you can every single day, right? Don't allow that one to slip. Have continuous integration running on every single check-in. That's a success pattern, right? Get your deployments agile, right? Making sure it's easy for you to deploy what you want, when you want, and that sort of don't have to worry about that stuff. Those are all success patterns, right? So I think if a project in Apereo was is to be agile or is to get agile, I think in a sense we've got to reel the scope in and say, okay, what can we attack in that way? The presentation I just came from about WAD, which is an awesome acronym. Thank you, Shoji. It's like that's like that kind of scope. It's like we're building a tool that's going to integrate with CLE, right? And all of a sudden, the boundaries are a little smaller, and now we can apply these success patterns to those efforts. And maybe we won't get all of CLE ever, right? But all the new stuff, right? We should start on the right foot. We need to start using, success patterns. And so, I would say any new development would be a great, great place to apply those techniques.
As compelling as it is, it's going to be a tough sell.
It's a little like, I think CLE sort of reached that part. Like, it does so much and it's so fast. It's actually like now the real thing to do is shrink it. Now it's a little bit counterintuitive to how they've operated as a
I
community.
just see what you're
because,
saying.
we have 6 competing tools in some cases and all this kind of stuff. And that's what you get from the open source community a little bit, because it's that Darwin kind of philosophy, right? The best one wins. You don't like it, go do what you want. But there's obviously a lot of poor efficiencies in that, and things get half done and not fully. So I think we've got to get better at kind of figuring out
Well, that's kind of
with the
interesting
leadership
that you
whatever
mention
it's
that, John,
here.
because there have been efforts in the past to create minimal versions of CLE in the past, even with the build tools that we had previously. And I think that effort failed previously for a variety of reasons. But applying this new technology, this DevOps approach to it, actually might help it to succeed where people
Yeah, I think there's still process things that need to get worked out. This stuff's already, a lot of it's already on the table for discussion this afternoon. But like indies or not indies and our release process and all like this stuff is kind of core to some of that. I think we have to get that stuff. There's actually some. I've heard some people just actually have resistance to automation. Actually, like we don't. There's this like we don't trust it because we tried that before and it's gone bad. So we need it to be more manual. Like that, we got to bust through that. That's not a success story. You know, that's an old person.
And certainly we will continue to look to a Sunny Net for that.
Yeah, so I think, as much as anything, I don't want to get too philosophical, but it is, in my mind, it's kind of a call to arms. It's, it's like if we don't take care of business in these ways today,
Business will take care of us.
I was going to say, it will take care of us one way or the other. So,
I mean, and I think it's worth pointing out that it is actually sort of an upfront investment, and it's a month that you need to get over.
Yeah.
And it is some work that you need to do, but I mean, we've gone through the work, and having done it, it's only after a couple of months or maybe even a couple of years that you really start to see the benefits. And so that makes it a harder sell, but once you have done it, it is actually necessary. One of the great disadvantages that this community has compared to the market space is that we actually, development doesn't really run things in production. That's a huge disadvantage, so we really need to be doing it.
right.
Yeah, I mean, I think that's a little bit what I was just going to say. I mean, well, one thing, it's not just the upfront investment. It's you have to continue. Right? You have to be committed to the test. You have to be committed to continue anything new thing you put in there has to be automated. So there's always a little committed support, right? And I think that's the other point is right. Ops is right. It's like resource. Angry guy in a dungeon, cultural aspect. People think that and engineers, we're throwing features, and it's just like Jekyll and Hyde. But developers can't think we have to embrace ops and realize how important it is, and get all excited like Lance is, and see the engineering capability in it, and not treat it like it's that dark dungeon, right? I mean, I think we have to embrace it.
Yeah, in a sense, quality is something that you can't add in the end, right? You're going to do a bunch of development, and then, in these last 4 weeks, we're going to add quality, right? It doesn't work that way, right? And the same way with operations, you can't be I'll let someone else worry about that. I'll hurl the speed pit of goat over the wall and hope that person on the other side can deal with it. It just, those days are over.
And what's the test coverage in CLE these days?
That's a good question.
I don't know, but it's certainly nowhere near the 95%.
And part of that, and we've known this for a long time, is to build good code, you have to build code that's testable. And CLE sort of started off on the wrong foot. It was actually very hard to run unit tests in CLE, and so it was sort of a fight from the very beginning.
That's some of that.
Yeah, that's
And that's not true everywhere. I mean, yeah, John, you've done some really cool stuff lately.
The Elasticsearch stuff is a good example of that. Nikita, there's tools out there that really help, or things that even we always have lots of all that. Right? So things that talk to servers. But there's if you look, you can find it's here's an embedded LDAP server. Spin that stuff up and read it. If you get creative, you can actually solve these things. And you find actually they don't take that much time on it.
Right. Okay, so I think we need to vacate the room here. We've got some more people waiting. Thanks, everybody. And yeah, if you have more questions, just grab us in the hall. We've got plenty of time.